This is a Unit 10 Geometry Review video, filmed in front of a live studio audience. Thank you. Thank you. Okay, number one, I'm going to go ahead and label our figure. Vy is 4. Ooh. Hang on, I have an echo.
I like the echo.
Fair enough. Okay, Wx is 11. Really is like being in front of a live studio audience. And Vx is 5. We want to find the length of Wz. Now, if you remember from this unit, you want something small. We have a small triangle and a large triangle, which is xwz. Something from the small and something from the large. So I'm going to set up a proportion and say, hey, 5 over 11. 5 is to 11 what 4 is to Wz. Just setting up a proportion. Now, 5 times Wz equals 11 times 4, which I'm going to go ahead and write down as 44 right now. Divide by 5, 44 divided by 5. I bust out my trusty calc, and I get 8.8 for the length of Wz. Number 1 is finished. Whoops, gotta have a decimal in there. Number 1 done. Number 2. These triangles are similar, as stated. PM, the length of this large side, is 15. PO, the length of this small side, is 10. PQ, also a small side, is 11. Notice for this side right here, I know both the small and the large length. That will be very useful in our proportion. I also want to now find the length of P to N. Hey, that's the big version of PO. If you do this right, you won't say PU. Laugh track, excellent. Okay, so 11 over 15 equals 10 over Pn. Using my proportion and cross multiplication, 11 times Pn equals 15 times 10, which is 150. I divide by 11, 150 divided by 11.
13.63.
Wow, 13.63. What an audience. Not only are they kind, but they have correct answers. Great job, audience. Now I want to find DF in this next one. Okay, once again, similar triangles. We want to find DF. So, I've got to figure out what's going on here. AB is similar to 2C, or EF, because they are the first two letters in each one, and by looking, by inspection, you can see they're the same. So I'm going to set up a proportion. A over 2C equals 4B over FD, or DF. As you can see, this is similar to this, so this is similar to this. Anyways, we're solving for DF. We have DF times A equals, I'm going to combine these and make it 8BC. If I now divide by A, I get DF all alone, and my answer is 8 times BC over A.
1, 2.
Great work. Great work, you guys. Hey, let's keep trucking now. There's one in every crowd. I will move on through the pain. Nate Bile. All right, next one. If this angle is 60 degrees, this angle down here is 60 degrees. Alternate interior angles. So, angle Z is known to be 60 degrees because I'm making the executive decision that this is parallel to this, which I believe should have been marked. Now, if I want to find WZ, the length of this bottom side, I'm going to set up another proportion. Notice that this side and this side are similar, okay, because these triangles are flippity-floppity, and it tells you they're similar, okay? So this is going to be similar to this. Notice that 5 doubled is 10. Therefore, 7 doubled would be 14, and the length of WZ is 14. I hope that's a sufficient explanation. On to the next page. Only 4 more, and then we're finished. Are these triangles similar? Well, I notice that I know all 3 sides in each triangle. So I'm looking to prove via the SSS similarity theorem. In order to prove by SSS, I need to make sure that they're proportionally the same. So the smallest from this triangle is 18, and the smallest from this triangle is 24. 0.6. I put 18 over 24.6. The middle from this is 24. The middle from this is 32.8, so I put 24 over 32.8. The largest from this is 30, and the largest from this is 41, so I put 30 over 41. I want to see if these ratios are the same. 18 over 24.6, ooh. 24 over 32.8, ah. 30 over 41, ding, 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 ding. They're all the same. Therefore, you say yes by SSS. Gosh. Good thing you can't see me right now. I'd be blushing. Number 6, are these triangles similar? Well, that's a good question. Now, you should recall that there is a triangle similarity theorem called AA. You just need 2 angles in a triangle that are the same. Well, I see one that's the same in each one, but the other ones don't look to be the same. But before you just move on with your life, make sure you do what?
You have to make sure that all the angles have to 180.
You do. So let's find that missing angle.
Okay.
So 180 minus 30 minus 55, this angle is 95 degrees. And you say, oh, in fact, I do have 2 angles that are the same. This is yes by AA similarity. So there you go.
1, 2.
Wow. Okay, a flashlight beam. Only 2 to go. I wish there were more, but there's just not. It projects a triangle with sides 4, 5, and 6. Well, that's great. Onto a screen. If the longest side of the triangle on the screen is 48, what are the measures of the other 2 sides? So we've got similarity here. 48 and 6, they're similar. Okay, so I can do it a lot of different ways, but I can say, hey, 6 is to 48 what 5 is to mystery side, and cross multiply. That'll find me that side. Okay, so 48 times 5
is 40.
240 divided by 6 is 40. So I have a side that's 40 inches. And to find the smallest, I can just say, hey, 6 over 48 is the same as 4 is to what? Okay, so now I come back here again, and I do 48 times 4, and I divide that by 6. Ooh, 32. So my other 2 missing sides are 40 and 32, just by using proportions once again. Okay, the last...
2.
Oh my gosh, how kind. Have you ever seen an audience like this? My goodness.
Oh, yeah.
My goodness. Number 8. A toll booth is located 3/4 of the way up a 2,640-foot ramp as shown. That means this whole ramp is 2,640. Well, don't be a dummy. 3/4 of that is 3/4 of 2,640. Oh, that means the toll booth is 1980 up the ramp. Look at that. I know both the small and the large of that length up the ramp. Looks like one side of a proportion to me. Anyways, the first pillar is 360 feet high. That's this distance right here. The next one is 1940. Oh, I don't know this. Find the height of the pillar at the end. I'm going to call that, let's call it A. Sorry about the confusion. You can call it anything you like. I'm going to call it A. So setting up a proportion for this, I have my small, 1980, over my large, 2640, equals my small, 360, over my large, which is A. With a little cross multiplication, I can take this down. 2640 times 360, that's the big number there. But then I divide by 1980. And I get the height of the pillar at the end of 480. When I said take it down, I meant the problem, not the pillar. That would be bad for the bridge. Right? Bad for the bridge. It needs it to stand up. All right. Woo! Good thing we're almost done. Okay. Let's see here. The distance on the ground from the lower end of the ramp to that pillar is 1948. I assume they mean this first pillar. So this small distance. Oh, and what do I want? I want to know the total ground distance all the way to the second pillar. I'm going to call that distance B. Once again, I'm going to set up a proportion using the thing I know both parts to, small over large. And now I know the small, 1948, and I want to know the large, B. So with a little bit more cross multiplication, 2640 times 1948, and I divide by 1980. I get the length of B, the ground distance, to be 2,597.3 repeating. I should have done units. I believe these are in feet. Yes, they are.
1, 2.
Happy birthday, Carson. It's been real. Enjoy your Chapter 9 review, everybody.
YOLO!
Thank you. Thank you. You were great. You've been